Hello everyone, it is another lesson for you today talking about rational functions. This lesson, I will teach you how to define a rational functions. A rational function can be written in the form f of x equals n of x over d of x, where n of x and d of x are polynomials and d of x is not equal to 0. As you can see, most of the form were attached to each other so that we can also define if it is a function or not. For some example, I'll show you some given that are a rational function. These are a rational function. F of x equals to 1 over x. Other is g of x equals to x over x squared minus 9. The other is h of x is equals to x squared plus 1 over x minus 1. Consider to all of this a function in which the denominator of polynomials is not equals to 0 and the numerator will be a polynomials in which it has correspond to each numbers to all given. And lastly, I of x, for example, another example, is equals to 3x over 2 minus 5x minus 2 over 3x over 2 plus 1x plus 2. This example is a function just because the numerator is a polynomial and the denominator is a polynomial in which it's not equal to 0. The form of the function, here are the details. F is a constant divided by a linear function. G is a linear function divided by a quadratic function. H is a quadratic function divided by a linear function. I is a quadratic function divided by a quadratic function. As it told you all about a rational function, basically there's some knots, or what we say, not a function nor not a rational function. For example, as I wrote down here, f of x equals square root of x over x plus 1 and g of x equals x plus 1 over 1 plus x over x power of 1/2 minus 4 x power of 2. And lastly, h of x equals the square root x plus 1 over x minus 2. What can you see or observe stated here below? Stated rather. For example, as I wrote down here, f of x equals square root of x over x plus 1, and g of x equals x plus 1 over 1 plus x over x power of 1/2 minus 4 x power of 2. And lastly, h of x equals the square root x plus 1 over x minus 2. What can you see or observe stated here below? Stated rather. By identifying as a simple way, it could be more specific if you observe the given forms that it has a square root or a fraction, squared and a fraction, like this. The ones who can observe this is not a function. You can observe the function has the right way of determining a function. On the other hand, this is not a function. The numerator of f of x is not a polynomial because polynomials do not follow square root of the independent variables. Example, f of x, the square root of x over x plus 1. F is not a rational function. Similar to the denominator of g of x is not a polynomial because fractions are not allowed as exponents of polynomials. Defining a rational function. Some simple ways are there to give some specific answer. Example, f of x equals to 2 plus x over x plus 2. Solutions are rational function Both numerator and denominator are polynomial. Both of the denominator and numerator. On the other hand, defining a not rational function. Example: h of x is equals to square root of x plus 2 over x power of 2 x squared minus 4. Solutions. What are solutions? This is wrong, not a rational function. Why? Because all of it is not following a square root. Simple as that. Do not follow square root as well. So it is defined as not a rational function. As you learn the rational functions and defining all of it, I will give you some quiz bees and try to define whether it's a rational function or not. Game? Okay. Items number 1. Try to define whether a rational or not rational function. Done? The answer is not a rational function. Why? First things first, not following a fraction in an exponent. Items number 1. Try to define whether a rational or not rational function. Done? The answer is not a rational function. Why? First things first, not following a fraction in an exponent. Items number 2. Define whether this is a rational or not a rational function. Done? The answer is a rational function. Why? Because it follows a polynomials in which a quadratic functions. Thank you for watching. Hope you enjoyed the show. And don't forget to like my page and subscribe for my channel. And hope you enjoyed well and learned how to define a rational function. That's it for today, folks. Thank you. Good day. Hello, everyone. Ah, ah, ah. Where n of x and the... Ayaw ba?